You've chosen, okay. Yeah, so this is an electric kettle. I have just opened this. Like I was telling you earlier on, to remove screws or open them, you turn anti-clockwise, like the direction opposite to what your clock second hand would move. And this gets out, place it aside, and then I notice this is just locked into place, so nag it a bit around like that, and then will come out. Now this thing's handles is a bit faulty, just because the washers on the other side that's supposed to hold it tight are off, but anyway, we'll deal with that. Right now this thing doesn't work, at least that's how much I've been told. Let me just test that to prove. Now, one thing I want to tell you, if you really want to understand the concept about electric kettles, it has that heating element right there. But the way of internalizing that heating element there, just look at it as a resistance wire. Now that wire has some sort of resistance, and when you run current through it, you know that power is energy divided by time. So the energy produced, in other words, the heat energy, is power times time. And we know that power is current times voltage. So voltage can be voltage in terms of resistance is what? V equals to IR. Yes. V is equal to IR. Since power P is I times V, but V is I times R, so that means power is I squared times R, R being the resistance. So if you have a resistance and then you run current, which is I, through it, it produces power. Now for the time it takes, when you multiply that by the power, you get the heat produced. So anyway, that's just a theoretical thing. I don't know whether that made sense or you've understood. But yeah, so what I was trying to say is that the heating element is simply a resistor. So if you understand resistors, basically you know what the heating element is. Of course, now a pack on top of the resistor that produces heat, you definitely have a switch, and you know a switch is just something that breaks and makes electrical contact. Now the other thing is also a mechanism to allow it turn off when heat builds up. Now that is achieved by using a bimetallic strip. Bimetallic strip is basically two metals of different thermoexpansivity welded together. One expands faster than the other, causing it to bend. The shorter one is expanding slower. The one that expands faster will expand faster. So that causes a force that pushes the switch to go off when it heats up. Then when it cools down, it goes back to its normal state. Anyway, let's just go in. Maybe I'll show you those in implementation. So that's an automatic electric kettle in brief. A resistance wire or a resistor, a switch, and then something that senses temperature, that is a bimetallic strip. Okay, bimetallic, bimetal, like two metals. So I need to remove this. Is there any other screw? I don't think so. Is there? Is this a screw? Yeah, it is. Unfortunately, it was looking black. I don't know whether that's because of soot or because they painted it black to make it look hard to open. So manufacturers also have that tendency of concealing screws because they don't want you to repair them. Now, for now, I'm going to pick out this entire mechanism, because this black mechanism is what is housing the switch and the bimetallic strip that operates the switch. Okay, so these three screws here, 1, 2, 3, are the ones that hold this onto that, and then this is basically a rubber seal to prevent water from coming outside when it is placed in. So that, let me turn this. You first turn them partially. Okay, I should be able to remove this plastic red thing off, make my life a little easier in accessing that. So this is to just operate that mechanism, the switching mechanism. Alright, okay, so I've loosened the 3 screws. That means they are all able to open. So that's out, this is out. And now, if you might know, these are screws, and I think they used to teach us in Form 1. Now the distance, these things that you see that poke out are called threads. It's like threads are winding around. Now the gap between 2 threads is called a pitch. Yeah, that's just actually a screwdriver is considered a wedge. When you look at machines, it's looked at as a wedge that can rotate in. It uses the principle of the wedge. Okay, and then these that you're seeing are just washers to improve or increase the surface area that the screw exerts the force over. Alright, then you can hear the heating element fall. Let me just pick that screw out. So when I say heating element, this is basically the heating element. And someone may be asking, how is it unable to shock me when I touch the body yet power is running through? So anyway, what you're seeing on the outside is just a tube, metallic tube. Now that metallic tube has a thin wire that runs inside. If you look this piece of metal that you're seeing is not connected to this in any way, but this is connected to that tube. So it's like a tube, and this resistance wire that produces it simply runs in the center of this tube, moves around, and then comes back to here. So basically these are the 2 ends of that wire. If we were to unbend this, you would realize the total length of the resistance wire is the length of this entire coil. Now, how that resistance wire is prevented from touching the outside of the tube, normally they use silk, I think sort of like sand, that goes around, that surrounds the resistance wire. And then yeah, so that's how electricity doesn't reach you. There's no direct electrical contact between that point and that point. Let me just prove it to you with the multimeter. Now this is a multimeter, and right now I've put it down here in diode mode, continuity. And when something has a very low resistance, under 5, which is typical of metals like that, it will beep. When I put it on this metal, you can hear it beep. So now I wanted to actually show you. Okay, you see, like this measures resistance. I put it in continuity, but here I've put it to measure the lowest resistance value, so it can actually beep when I touch metal, because metal has a resistance of under 5. You see, screw and screw. The body here, that's metal. Now between here and here, you notice that nothing happens, because this outside is not in electrical contact with this. This outside is just in contact with that piece of metal like that, but not with this. That's why the water won't shock you, or the body won't shock you, because it's not in electrical contact with the parts that are taking in live power. However, because I told you that this runs through this tube and comes like this to this end, so that means this is a continuous metal up to that point. So when I put the probe here up to there, you can hear, I hear a beep. That means that wire is running in the middle of this tube and ending up this side. So it's also another way of testing whether this is dead. If I put this here and to the other end of it and I don't hear that beep, that means that wire in somewhere there is broken or burnt out, and therefore your heating element is dead. That's an electrical kettle for you. The heating element is just a pure big resistance wire. I don't have a multimeter that can measure resistance value, but usually you find it lying between 30 ohms